try to present a couple of example problems for using cake. Um, Cake, of course, refers to the the constant acceleration kinematic equations that we use for one-dimensional motion where the acceleration is constant. So these are, it's very important to remember, these apply to constant acceleration only. And I am not, okay, acceleration only. Okay, so the first example I'm going to give has to do with Superman over here. I found this online. This is what they used to say about Superman. When he was first created, he couldn't fly. The writers had not thought that flying was, or it hadn't occurred to them, I guess, that they would want him to fly. So they said he was able to leap tall buildings in a single bound. So really, he just had to start on the ground and then jump. So what I want to know is to leap over the Empire State Building. The Empire State Building, which is 381 meters tall. Building 381 meters tall. That's one of those things you tend to remember when you're a physics teacher because it comes in handy. What speed? What initial speed does Superman have to leave the ground with? Must SM jump with. So this is a, sorry about the handwriting. I'm learning to use this tablet with my new Mac, and I like it. This is actually much better than this thing used to be. This kind of thing used to be, but I'm still working on it. So anyway, what initial speed does he have to jump with to get over the Empire State Building? So it's always helpful in these problems to draw a little diagram. Here is the ground. Here is something that looks kind of like the Empire State Building. And here is Superman at the start. I'm not going to worry about whether he can get, up and over horizontally. Let's not worry about that. I really just want to know how high does he have to jump, or sorry, how fast does he have to leave the ground in order to jump over, or in order to reach a height of 381 meters. So I'm going to say this is the height up here, and I want to define, let's see, what am I looking for? Is that an eraser? No, it's not. Great. Is that an eraser? Yeah, that's an eraser. Sorry, Mac stuff. I'm not good at it. So anyway, actually this is Sketchbook Pro, which I just downloaded. So, or Sketchbook Express. Sorry, the free one. I'm a teacher, right? I can't afford the professional version. Okay. So anyway, what I want to do is first set up my axes. So I'm going to set this up and say this is going to be my positive, and I'll just go with y for my axis here. Why not? That was not intended to be a pun. Okay, so what I'm going to say is that Superman starts here on the ground, and this is state 1, and then up here, when he's at the peak of his jump, this is state 2. So I want to write down basically everything I know about these states. There's position, velocity, and time, right? So position, velocity, acceleration are the three sort of variables that are important at any given point in time. Okay, so first of all, my acceleration here is constant because it's just the acceleration of gravity. This is what's called a free fall problem. So I can write A equals, in this case I'm running negative g because gravity is pointing downwards. Remember that g is always a positive number. I'm trying to draw my little two-head gravity arrow or acceleration arrow there. Okay, so remember that gravity is always, little g is always a positive number. So if we want to be accelerating in the negative y direction due to gravity, we need to say that acceleration is equal to negative g. Okay, so that's constant for everywhere. So everywhere acceleration is going to be negative g. And then we have velocity and position are going to change. So at state 1, I'm going to draw a little arrow here in here to say at state 1, what's our value of position? And this depends on where we decide to set our 0 point for the y-axis here. I like to draw a little horizontal line for that, so I'm going to say right here at the beginning, y equals 0. I'm going to say y1 equals 0. And then velocity at state 1 is going to be whatever his initial velocity is. And that's what we're supposed to find, right? So I'm writing question marks for that. Okay, now up here, what I really want to do here is say that at state 2, what do I know about his position and his velocity at state 2? Well, to start with, his position is going to be h, which I am saying is this, this height, 381 meters. I'm leaving it as h for right now, so I can plug this in later. And then, I'm sorry, that's not supposed to be a y. That's supposed to be a v. So, man, that's some sort of smearing thing. Let's see. I'm sorry, I just learned to use Autodesk. Is that doing it for me? Maybe. Okay, so I'm trying to make that into a v. I really need just like a thicker marker pen thing. Okay, so v2 is what's his velocity when he reaches maximum height? Well, if you think about it, maximum height, he's going upwards until he gets there, right? So his velocity is going to be upwards for this part, and then his velocity is going to be downwards for this part. So it's a positive number here. This is velocity is greater than 0 as he's going up because his y-coordinate is increasing, and then velocity is negative as he's going down because his y-coordinate is decreasing. So when he's right there, that's when his velocity is changing from positive to negative, which means at that instant, when he's at the very top, v2 is 0. Okay? So now we are all ready to do this. We've got, acceleration we know y1, we don't know v1, we have to solve for that, but we know y2 and v2. So now we want to just find some equation that will let us, use these things. So there's no time in here. You notice that we don't ask for time and we're not given time. So we can use then cake 3, which is v2 squared. The final velocity squared is equal to v1 squared, the initial velocity squared, and then plus 2 times the acceleration times delta x. Okay, so let's go ahead and figure out what these things are. We want to use v2 squared equals v1 squared plus 2a delta x. Boy, I hope this is big enough as you're watching it, wherever you're watching it. So delta x, actually what I should do really is use delta y, right? Because I've already used a y for my position variable. So let's go back here and fix that, and delta y. Okay, so delta y is going to be the change in y, right? That's what delta anything is, the change in that thing. So y2 minus y, whoops, let's see, sorry. Okay, y2 minus y, and now I've moved the canvas. Oh boy, what can I say? I love this Mac now, but I just have not gotten used to it. So that's going to equal y2 is h, right? We already found that out, and y1 is 0, so h minus 0, which of course is just equal to h. So that tells us, we figure out what delta y is. We know that acceleration is negative g, right? And so it's that. Delta y, v1 is our unknown, and v2 is 0. So what we're going to do is say 0 squared equals v1 squared, okay, plus 2 times negative g times h. And so, of course, this just becomes minus 2gh. And what I'm going to do is take this whole thing here and flip it over to the left side. And now I'm going to say 2gh equals v1 squared. And then it's not very hard because we want to solve for v1, right? We know g, we know h. So I am going to take this here and bring it over to this side. So this is just a little note for cake. So I'm going to bring this over this side and say v1 equals square root of 2gh. So h is the height of the building he's jumping. G is the magnitude of gravitational acceleration. 2 is 2. And we put those things together, just take the square root, and we will get, we hope, the initial speed he needs. So now I'm going to actually put this together, and, well, now I have to find a calculator, or somehow I have to plug these in. So it's going to be 381 times g is 9.8, almost 10, and 2. So 20 times 381 is going to give us square root of 72 600 approximately, okay? So I'm using a little trick where I like, because I have to do this in my head. I didn't think to get a calculator ahead of time. So I'm using a little trick I like where you can plug in g equals 10 if you're trying to do things in your head. Because it's close enough, right? 10 is 2% off of 9.8. Don't do this on WebAssign because WebAssign will ding you for being more than 2% off sometimes. But when you're doing things on a quiz or a test, for me anyway, I don't speak for another teacher, but for me, Dr. Smith, it's perfectly fine to use 10. Let's see. So this is going to be a square root. So the square root of 6,400 would be 80, right? And then the square root of 8,100 would be 90. So it's somewhere between 80 and 90 meters per second it needs to start at. And I really can't say exactly, but approximately 85 meters per second, give or take. Actually, I feel like now I remember, because again, I'm a physics teacher and I've done this kind of, I've done Empire State Building jumping problems before. I really feel now like it's 84 meters per second. And I want to say V1 equals 83.7 meters per second. Maybe, okay? That's like familiar to me, but I don't know. So one of these somehow pretty close is how fast Superman would have to leave the ground when he's jumping. So I hope this gives you a little idea how to start applying equations like this, the cake equations especially. I will do one more problem that's a bit trickier in just a moment in another video. So stay tuned.